Okay, welcome to this video on equations of lines, finding equations given constraints. This is a pretty big topic, so we probably will go over into a second video. We'll just pick up where we left off. Alright, why do we learn about equations at all? Well, one reason is because mathematics can be used to model the real world. So we might want to come up with an equation that is going to somehow help us solve a problem or to model the real world in order to answer questions about the real world. Okay, let me give you a real world example here. The problems in this section that you're going to be tested on eventually in the class at first are not going to be like this, but I at least want to set the stage to show you, why would we want to make equations, right? And then we're going to move on to more abstract, how do I just come up with equations that model situations. But just to put it in context, here's a real-world situation that we can use an equation to model and then use our equation to solve the question. Okay, a car is worth $20,000 new and it's worth nothing in 20 years. If we assume that its value drops steadily, in other words linearly, it's dropping like a straight line from 20,000 when it's new to 0 at 20 years, then what would the value of the car be in 14 years? Okay, that's a reasonable question to ask. Alright, so let's take a look. Maybe we can start by trying to kind of graph the situation. Here's a graph that represents the situation, and what we've got is I've got time across on the horizontal axis moving off to the right in years, and then I've got the value of the car on the y-axis moving up vertically, right? So there's really two data points that we have right now. We know that when the time is 0, when the car is new, when time is 0, the x value is 0, then the y value, the value of the car, would be $20,000, right? So 0, 20,000 is one of the data points that represents the situation, right? And the only other data point I have is that at 20 years, when time is 20, when x is 20, then the y, the value of the car, is 0. So two data points, and there's a straight line going between them. All right, so my goal is to come up with an equation to model this line, okay? Well, let's see. What do we know about equations? So there's a lot of different forms of equations, right? There's a standard form, a general form, a slope-intercept form, a point-slope form, and we also have the slope formula. So there's a lot of things we know about equations of lines. All right. So first what we have to do is pick what we think is going to be a good model. Well, I'm trying to figure out the value of the car in 14 years. So I really want an equation where I can plug in a time, an x value, and then I can get out the value, a y value. So I want to be able to plug in x and find a y. And as I look at these, the one that seems best is this one, the slope-intercept form, because it's already solved for y. So I'm going to be able to plug in some value, 14 in here for the x, and then I could find the value of the car. So it looks like I really want to get that right there. I'm probably going to also need the slope formula because this formula contains the slope. Okay, so let me get some of that off the screen and let's actually look at that a little bit more closely. Okay, slope-intercept form of a line, y equals mx plus b. I want you to know something about these generalized equations. Okay, they're full of letters, right? Some of the letters, right, the x and the y are the variables, right? Those are the variables. And those things are expected to stay x and y in our equation, right? Because we need to be able to plug values in for x and find y, or plug values in for y and find x, right? Now, the other two letters, the m and the b, are called constants, okay? Now, right now they're letters because we don't know what they should be, but when I have an equation that models this line, the m and the b will be filled in with numbers, right? So my goal in trying to come up with an equation is basically to figure out what should m be and what should b be so that I get a line where the equation models that particular line. Okay, so I'm searching for m and searching for b. Okay, so let's see. M in this equation means slope, and I have a slope formula that will help me find that if I can find two coordinate points, right? So I have two coordinate points here. So let's just call, maybe this one down here, we'll call x1 and x2. Yeah, let's do that. Let's call this point down here point 1. So I'm going to label this x and y for point 1. And this one's going to be x and y for point 2. Okay? And so I'll just plug things into this formula, right? Let's see, I have 20,000 minus, for y2 minus y1 would be 0. And then x2 would be 0, and x1 would be 20. And so that means the slope, which I'm going to now call m, is 20,000 divided by negative 20, which simplifies to negative 1,000. So that means that I've now figured out from these points what my slope of my line has to be. So I can start writing it out. let's write as much as I know. I know that the m has to be 1,000. Okay. So at this point, I've replaced one of the constants, m. I now know what the number should be, but I've got one last constant left. I still need to know what the b is. Okay. So now a general way that you can do this is you can now pick a point, like for example this point, and plug in the two values that you're given for x and y, because that point, 0, 20,000, must make my equation true, right? So there's only one value of b where if I set that properly, then 0, 20,000 will make the equation true. So one way to do that is to take my equation and plug in 20,000 for y, and plug in 0 for x, and then solve for b. Okay, so I'm going to do that. Let's see, what I've got here is 20,000 equals, well, 0 times negative 1,000 is 0, plus b, and that means that the correct value for b is 20,000. And so now I can write my equation one more time. I'm going to go back to this version, and I'm going to write it over again. I already know that the m is negative 1,000, but now I found out that the b is 20,000, so I can fill that constant in now, right? All right, excellent. Now I've got an equation. Now this equation is a model. It represents the car situation here. I could now plug any value that I want in for x, and I can find the corresponding point for y. So what it's telling me is, now let's use it. It says, what is the value of the car in 14 years? So what I want to do is I'm going to plug this 14 in for x, and then see what y is. Y equals negative 1,000 times 14 plus 20,000. Okay, so y equals, let's see, that's going to be negative 14,000 plus 20,000. And so that's going to be 6,000. Okay, so I know that in 14 years, the car is going to be 6,000. And in fact, if I plug 14 in for x, y is 6,000, right? Okay, so that's what's meant by using an equation to model a situation, right? What we did is the equation had some variables, had some constants, and I found ways to figure out what the constants needed to be. Okay, I know that this is complicated looking, right? But you should know why we're learning it. We're learning it because mathematics can be used to do useful things like this. Let me extend this problem a little bit further even. Now we have an equation, y equals negative 1,000 x plus 20,000, that represents this situation. Let me extend the problem a little bit further. Let's say a different car loses value at the same rate as the car in the previous example, but this time the starting value for this new car is only 12,000. Could I write an equation that shows the value versus time for the new car? Okay, well here's a situation, right? We've got the old car started at 20,000, dropped at a certain rate, right? And the new car starts at only 12,000 and it drops at the same rate. So that means that the line representing that value is parallel to the first equation, the equation we had before. So let's look at that equation again, right? We have, for the blue line, we had this right here. Y is negative 1,000 x plus 20,000. So how would I make my equation for the second line? Well, I've got to start over again because I have potentially new constants for m and b, right? But if this line is parallel, then I know the slope has to be the same. So I already know that the m must also be negative 1,000, right? The only difference is that maybe b is different, right? So now I'm going to go to this point and plug that point in for x and y to see what the value of b should be. Well, for y, it's going to be 12,000 equals negative 1,000, and that 12,000 happens when x is 0. So I'm plugging 0 in for x, 12,000 for y, and then I'm going to solve for b. And so b is 20,000, so that means that this equation would be y equals negative 1,000 x plus 12,000, right? Which, now, I did that intentionally that way, even though we know that that number out there is supposed to be the intercept, because this is a generalized way to solve. All right. Okay, complicated, I understand, but hopefully shows the point of why we do these things. Okay, here's a general procedure that we can use for creating an equation to model a situation that has constraints, has things that have to match certain parts of the problem. First of all, you need to select a general form equation model. That model will have variables and constants. Second, you need to try to obtain some of the constants in some way from the problem. Slope might be obtained from points in the slope formula, or maybe it's just given, or maybe it's got to be parallel to another line like at this last problem, or perpendicular. And then the third problem is pick a point that's on the line and fill in the values for x and y so you can solve for the last constant. Okay? Now I've used up a good chunk of this video just giving you an introduction essentially. The problems you're going to be asked to do on the quiz first week of school are not going to be word problems, but I wanted you to see the connection to real world connections before we do this here. So the rest of this video, and we'll go into a second part, is going to be solved examples. Okay? But these will just be generic XY kind of equations without any connection to word problem. Okay? Alright, here's the first one. So write the equation of a line in slope-intercept form, which contains the points 0 to 20,000 and 20, 0. Alright? Let's see. So I've got to have a line in slope-intercept form. So right there it tells me that this is probably the form I want to look for. Okay? So what can I do to find that? Wait a second. This is exactly the same problem that I just did, right? So I just wanted to show you what this looks like, right? This is the car problem, the first car problem that we solved, but I wanted to show you what this looks like if you just see it not in context. It might just say, write an equation in slope-intercept form, and it'll just give you 2 points. You would go through the exact same procedure we solved for before, just without the values. But rather than do that one, let me bump to another one since you've already seen this one. Okay, write the equation of a line in standard form, which has a slope of 2 and contains the point 1, 3. All right? Well, let's see. Standard form is this, ax plus by equals c. So I need to fill in these 3 constants somehow. Okay? But what am I given? I'm given slope and a point. So actually it seems to me like maybe what I should do is use the point slope form of a line. Y minus y0 equals m times x minus x0, right? That's point slope form. Because then I can fill something directly in, right? They tell me the slope is 2, so that means I'm going to fill it in for this, right? I've got y minus y0 equals 2 x minus x0, right? And just to go back briefly, there are 3 constants in this that I have to figure out, right? I'm able to find the m constant because they told me the slope should be 2, so I can substitute that directly. Okay, now what I'm left with is these 2 constants, x0, y0, but if this has to go through this point, then x0, y0 can just be the point that I'm given, right? In point slope form, it's any point on the line. So y minus 3 equals 2 times x minus 1. So that is the equation with all the constants filled in. The only problem is it's not yet in standard form. So let me write it over here again. And this time we'll do some algebraic manipulation to put it in standard form, right? So maybe I get rid of parentheses first. We have to distribute on the right. So I have 2x minus 2. And then let's get all the numbers together by adding 3 to both sides. Y equals 2x plus 1. And then standard form has x's and y's on the same side. So let's subtract 2x. So negative 2x plus y equals 1. But standard form can't have a negative here. So we would have to multiply the entire thing by negative 1 to get 2x minus y equals negative 1. Okay, that's the final answer. Okay, so you know, I picked an equation. This time I picked point slope because I could see that I could plug what I was given in there. All right. I think let's start the next example, and then we'll pick it up in the next video. We might not finish this example before we run out of time here. Write the equation of a line in standard form which has a slope and contains the point. You know what? Try this on your own, and then unpause the video and we'll see. Same thing. I think I'm going to start with point slope form, which is y minus y0 equals mx minus x0, because I can just fill in things, right? I can fill in the point y minus negative 2 equals negative 1/2 for the slope, x minus 6. So that's going to be y plus 2 equals negative 1/2 x minus 6. Okay? And then I need it to be in standard form, so maybe we get rid of parentheses. Multiplying everything by negative 1/2 here gives me a positive 3. If I subtract a 2, I get y equals negative 1/2 x plus 1. I would probably at this point multiply everything by 2 to get rid of the fractions. So I would get 2y equals negative x plus 2. And then you just add x to both sides.